Okay, we have the following non-linear ordinary differential equation: y prime squared minus 3y prime plus 2 is equal to 0, and y prime is the derivative of the function y with respect to x. That's a non-linear ordinary differential equation because you have y prime not to the first power, otherwise it would be a linear differential equation, but you have this raised to the second power. Most of the times when we have a nonlinear ODE, it's not possible to write down the solution explicitly, but here in this case we can do some tricks. We have y prime squared minus 3 y prime plus 2 is equal to 0. Okay, we change the variable w equals y prime, so my new variable is going to be w, and I have w squared minus 3w plus 2 is equal to 0. This is the quadratic equation. This is a trinomial. We can solve this by explicit formula. First we can calculate the discriminant is minus 3 squared minus 4 times 1 times 2. That's strictly bigger than 0, so we have two real solutions, w1 and w2. The solution of this trinomial is w1 equals 2 and w2 is equal to 1. But w is what? Y prime equals 2. dy over dx equals 2. dy equals to dx. I integrate. I take the indefinite integral on both sides plus a constant c1. Y equals 2x plus c1. So that's my solution number 1, y1. y2 prime is equal to 1. dy2 over dx equals 1. dy2 equals dx. I use indefinite integration on both sides of the equation, and I have dy2 equals the integral dx plus c2. From here I have y2 equals x plus c2. So the two solutions are, let's summarize, are y1 equals 2x plus c1 and y2 equals x plus c2, and c1 and c2 are real numbers. So the two solutions of these non-linear ordinary differential equations are linear functions, straight lines. y1 equals m1x plus b1, y2 equals m2x plus b2. So m1 equals 2, the gradient of the first line, and b1 equals c1, the y-intercept. And from here m2 equals 1, the gradient is just 1, and b2, the y-intercept is c2. So if we want to, we can plot also the lines. For x equal to 0, y1 equals c1, and for y1 equal to 0, c1 equals minus 2x, x equals minus c1 over 2. So the solution looks like this. For x equal to 0, the y-intercept is c1. Let's say it's positive, and for y1 equal to 0, the x is equals minus c1 over 2. Assuming that c1 is strictly positive, of course. That's one solution. We get a family of solutions. And for y2, when x is equal to 0, y2 equals c2. And when y2 is equal to 0, you have c2 equals minus x, x equals minus c2. So it looks like that. For x equal to 0, the y-intercept is c2. And for y2 is equal to 0, the x is minus c2. So that's another solution there. We started with a non-linear ordinary differential equation, first order. We have a first order differential equations. We have the derivative of the function y. And basically what we do here, we change the variable w equals y prime, and y prime is the derivative of a function with respect to x. Then we solve a trinomial, we get the w1 and w2, and then we know that w is y prime, and we solve two ordinary differential equations, linear ordinary differential equations, separable. We can separate the variables, and we get basically the solutions are linear functions, y1 and y2, depending on some parameters c1 of c2, which are real numbers, and the gradient of this linear function is 2, and the gradient of the second linear function is just 1, and the curves are just straight lines.